In this video, we are going to see different applications of matrices. Let's take an example. This is all about a consumer preference model. There are two companies A and B in a huge city of 100,000 households. This company offers cable television service. At the end of a year, in company A, 70% are retained, 20% switches to B, and 10% to no cable television. The same way, in company B, 80 are retained, 15 switches to A, 5 switches to no cable television. From the no cable TV group, 70% are retained, 15 switches to A and 15 to company B. Currently, if there are 15,000 subscribers in company A and 20,000 in company B, how many will each company have at the end of this year? And how many after 3 years, how many after 5 years, and how many after 10 years? They're also asking us to find what is the steady state. So this company A, it says the 70 are retained, 20 switches to B, 10 switches to cable TV. In company B, only 80 are retained, 15 to A and 5 to cable TV. No cable television, we have 70 retained, 15 switches to A and 15 switches to B. So let's convert this business problem, into a logical diagram here. So we have got two companies, company A and company B, and the circle represents that many people are retained here. The arrows represents how many are moving from one position to the other. So this diagram, whatever we have here, will lead us to create matrix table like this. See, if we are taking P to be in the probability matrix, 0.7 are retained in A, it says 15% are moving to B and 15 are moving to no cable, no TV. The same way, the second row, if it represents B, those are the corresponding probabilities what was given in the question. The last row represents no cable and no TV position. And also at present, the state matrix, that is the current situation, is that in company A, we have got 15,000 people, 20 are in B. And since the total in that city is 100,000, the 65,000 comes by adding these two and subtracting from 100,000. So this product gives us the matrix 23,250, 28,750, and 48,000 for no cable and no network after 1 year. Why is it we are multiplying these two? See, when we are multiplying this row along with this column, it looks like I am multiplying 70% of people in company A, which is 50,000, and 15% of people in company B, which is 20,000, and 15% of people, those who belong to no network, no TV and no cable, which is 65,000, will be, this total is going to be the number of people at the end of 1 year. So that gives me 23,250. So that's what I have here. The same way, when we multiply the second row along with this column here, we will get 28,750. And when we multiply this row along with this column, we get this one. So at the end of the year, we know 23,215 company A, 28,715 company B, and 48,000 will be in company C. So we know how much we got after 1 year. If the same transition probability continues, if the same pattern continues, then at the end of the next year, second year, we are going to have probability, that corresponding probability multiplied by the number of people in the beginning of the year, the second year, that is 23,250, 28,750, 48,000 will give you the total number of people after the year 2. So this is we are talking about the second year. But this we know that it is p times x. So we are multiplying p of px, which is nothing but p squared x. So after second year we have got p squared x. So in the third year it should be p cubed x. In the fourth year or fifth year it will be p raised to 5x. The same way in the 10th year it will be p raised to 10x. And there is a pattern here. In the nth year it should be p raised to nx. So we can easily get the value for the number of people after the 5th year, after the 10th year, by just using our graphing calculator, entering that in as a matrix. Just take p raised to 3, p raised to 5, p raised to 10, multiply by x. You can easily get these values. We also should note that sometimes we may get these as decimals, but always convert this to the next whole number, because these are all represents the number of people. So you cannot write that as a decimal, you take that as a whole number. That will be the number of people after 3, 5 and 10 years respectively. Now if you are continuing the same process, maybe if you increase the value of n, as n increases, at one stage there will be a steady value. So maybe when you increase from n 10 to say 20 or 25 or 30 or something, you may get the value as 33,333, 47,619, 19,048, or in other words, you will get a steady customers here. In company A, this will be the steady amount, and B and C. So it looks like company B has got more number of subscribers in due course. So here we all have rounded these values to the nearest whole number, and if you are interested in finding the steady state, this is what we have. See, this probability what we took here in the beginning, that probability is called the matrix of transition probabilities. And in it is an n by n matrix. And also when you add up all these probabilities, you will get the probability as 1. Total probability as 1. So it satisfies the rules of probability, which is the probability lies between 0 and 1. So since we take that as a decimal or a fraction, it lies between 0 and 1. It will not be negative. And also the total probability is 1. If that is the case, then you call that as a stochastic matrix. So this stochastic matrix plays a main role in solving problems in business models and in other scientific research. So this is the first application we are seeing. There are many applications of matrices. In our future videos, we will see the other applications of matrices and learn the applications of linear algebra. So in this video, we talked about the first application of matrix, which is in the business model. Hope this explanation was helpful and clear. Thank you for watching and thank you for listening. Thank you.